Welcome to the Virtual Mining Summit. This is session one, where I'll be interviewing Bruce Frederick, the author of the new mining CVD that goes through Curb and how it applies to surface mining. Some very cool things happening in the IoT BU in mining, and I'm going to have this conversation with Bruce. Bruce is a solution architect with over 30 years of industry experience. Bruce began his career in the U.S. Navy. And his mining experience began at Freeport-McMoRan. He was an architect there responsible for establishing highly reliable wireless networks from open pit and underground mining. His unique expertise led him around the world into some of the most remote areas of South America, Africa, and Indonesia. Some of you are very familiar with these places. And so I'm glad to have Bruce with us here. He joined Cisco about 6 years ago. We hired him into the advanced services environment so that he could actually work with Cisco solutions all around the world and actually implement them as part of Cisco. He's architected end-to-end capabilities for successful systems at many Cisco's Fortune 100 customers. Bruce transitioned to the global sales team as a TSA, technical solution architect, and focused on enterprise solutions. Some of you have heard about DNA Center, SD-WAN, location services, software-defined access. There's a whole bunch of things that we've been doing on the enterprise side. And so his experience there has actually been really valuable as he's come back now to the IoT world. He now works in the IoT business unit with a focus on creating end-to-end solutions for mining and oil and gas customers. Welcome to the conversation, Bruce. Glad to have you on the summit podium today.
Thanks, Roland.
Talk to me a little bit about CVDs, Bruce. What are they and where do people find them? This is these validated designs that you're working with.
Yeah, one of the super exciting things about Cisco is that we create Cisco Validated Designs. The Cisco Validated Designs are not a paper exercise where we look at data sheets and say, well, this product should work with that product and this application should be able to work on this product. We actually go and work with them. We set up the configurations. We partner with companies. We partner with manufacturers like Sandvik, with Caterpillar, with Komatsu, to be able to go in and look at their application and make sure that their application runs on our equipment. And then we publish a full configuration. So one of the things that's really exciting is that because most large mining customers have been built through acquisition, so they have a lot of hodgepodge all the way around the world. And so then they have to go and do proof of concept to see if this idea of tele-remote is actually applicable to them, and will it work for them. And so what we do with validated designs is we publish a full configuration, so now the customer has a blueprint. So now they know if you configure this equipment with this configuration, with this application from this vendor, it will work. So now it's no longer a proof of concept, now it's a proof of value. Will this blueprint bring value to your company? If it does, then you can have the reliance to move forward with it, knowing that it's been tested out already. It's not going to be a science experiment that you're going to be working on in proof of concept.
Yeah.
And if you look at IoT, in IoT, over 60% of all initiatives end at the proof of concept. They don't continue on past the proof of concept. So over half of the industry's time is wasted on doing a proof of concept to find out that it's not a good fit for their company.
Yeah. Wow. That's amazing. So obviously you can't solve all scenarios or can't test all scenarios. So you kind of choose some of the really kind of main ones that our customers are asking us about, right? I mean, I think you've done one of these before. I mean, this one's called version 2.0. What was mining version 1.0? Like, talk to me a little bit about that before we talk about this version 2.0.
Yeah, so in mining 1.0, what we did is we put together a reference architecture for the process control network area, where the smelters are at, where flotation, crush convey, all of those, so that you can look at the Purdue model and then how to have site survivability at the mine, but also how does it connect all the way back through. And so this was our reference to build off of. If you look at a lot of the process control, it's very similar to manufacturing process control. It has obviously its own differences, but you start looking at the IoT controls that are in there. So we put that together, and then we did a mining 1.5. In mining 1.5, we partnered with Sandvik. Sandvik is one of the largest underground equipment manufacturers, and we went out to their test mine. We configured with their stuff and made sure that everything works with their application. In our validated design, we put down which version of their application we're running. We put down what version of software we're running on all of our switches, on our access points, and then how they're configured. And then we moved on to the 2.0, which is the above ground. And in the above ground,
cool. So what, if I understand this correctly, Bruce, these aren't sequential, right? I mean, you're talking, these are all kind of different use cases, right? So they should almost be thought of as sort of three different validated designs for different areas of mining, right? I mean, 2.0 doesn't invalidate the other two. Is that fair?
That is 100% correct. With the only one that would be any exception is that the 1.0 is a great foundation. So as we look at, how does security, how does the Purdue model fit into for your extraction layer? That would still be a reference or a foundation for the 1.5 and for the 2.0.
Okay. Some of the products may have changed, I guess, since you published those, right? But the concepts are definitely solid, is what you're saying.
And then one of the things that happened between when we started working on our 1.5 and our 2.0 is that we acquired the company Fluid Mesh, which we now have rebranded to Cisco Ultra Reliable Wireless Backhaul. So once we acquired them, they have a great system for being able to have extremely smooth handovers, low latency, no packet loss off of it. So we have the capability then to use the Cisco Ultra Reliable Wireless Backhaul for connectivity to autonomous haulage, to tele-remote, to be able to use them so that they can have this high-speed handover and as it goes through it. It also has the point-to-point and point-to-multipoint. So this gives the opportunity for our customers to be able to set up their towers that they set up at the mine sites, to be able to get connectivity in remote areas using either the point-to-point or point-to-multipoint. And then from there, you can also use the towers for the point-to-multipoint to get down to the trailers. And from the trailers, then obviously you have the access layer to get to the equipment. One of the things that is nice about that is that it isolates the tele-remote, the autonomous system from the rest of the network. So by having it on the Cisco Ultra Reliable Wireless Backhaul, I don't have to worry about somebody else streaming too much video, somebody on the network and hogging space off of it, because it's really a closed network for that use case off of it. For the smaller operators in the smaller mine areas, we've listened to what they had to say, and we're working on a brand new product that will be coming out towards the end of this calendar year. And on that product, it will have the capability of either running the Cisco Ultra Reliable Wireless Backhaul, or it will be able to run in the 802.11 standard mode. So this will give customers it'll give the customers the capability of having a single SKU for sparing, for whether they want to do Wi-Fi or they want to do things that move at high speed, low latency.
So you just dropped a bunch of stuff on us here. This is very cool. I guess you're really testing the fluid mesh technology though in this CVD, right? I mean, this is the product numbers are a bit less important. So if we come up with a new new AP or a new infrastructure access point, they would work with this validated design. Is that kind of the idea?
That's correct. And then also as we bring in this new product line that we're going to bring in towards the end of this year, we will create a new validated design for complete configuration around it. And so we'll have the foundation where we have now. What's really exciting is that by having the mining 2.0, customers can move forward and know they have a path down the road too. It's not, okay, I'll deploy mining 2.0, and then when mining 3.0 or mining 2.5 or whatever we name it comes out, customers don't have to do a rip and replace. They know that we'll give a path from where they're at now to where they want to be in the future.
So question, like we pivoted to fluid mesh here pretty quickly. Like obviously the other ones weren't fluid mesh. Like I know that 1.0 was more foundational, I guess, but 1.5 with Sandvik was all Wi-Fi, right?
That's correct.
So what happened with Wi-Fi? I mean, that's obviously still a valid technology, and lots of people were using that above ground, some for AHS systems, right? So tell me a little bit about where we're at with Wi-Fi. Is that still something we're seeing people put out there?
It is 100%, and that's one of the beauties around it too, is that you can still continue forward with Wi-Fi, and then as the new product comes out, you could deploy the new access point in the 802.11 standard mode to continue your growth. And once you have enough critical infrastructure, you could then flip it over to a closed system for tele-remote or for autonomous, or you can continue running it in Wi-Fi.
Okay. Cool.
So it gives the flexibility.
So I don't want to talk too much more about the technology. I know that we're going to have a lot more about the technology tomorrow. Don Lane, who eats and breathes this stuff, and actually probably has been wanting to jump in and say some things. We're going to have a conversation with him tomorrow, and he's going to get to go a lot more deeply into the fluid mesh technology and the products and how they all work together. But just know that there's a validated design here that you can reference that's been tested and you tested this with Caterpillar, if I understand correctly, right? Tell me a little bit about how you do this with the OEMs. Like, how do you actually make this a validated kind of design with specific OEMs?
So on Mining 2.0, we did not test with Caterpillar. Caterpillar had already certified the fluid mesh, the FM4500 product line. And so they didn't have the time to be able to go back and then retest because they'd already certified it. So they agreed that in their mind, they had already moved past that. Once we get to the new access point, we will definitely be working with them. And we're currently working with them now on the Wi-Fi standard because of where we're at with the new 802.11ax APs that are coming out, the 9124 that are already available. So we're working with them on that. But on this Mining 2.0, we did not validate the fluid mesh with Caterpillar. So just to be clear.
So let's talk about the kind of the elephant in the room. Obviously, there's more OEMs than just Caterpillar and Sandvik. Those are ones that you've done the most intimate testing with. So what do mining companies do if they've got Komatsu or Hitachi or other OEMs?
Yeah, so we're working with the larger ones. We're working with Caterpillar, with Sandvik. We're working with Komatsu. We did not validate, obviously, either Mining 1.5 or Mining 2.0 with Komatsu. Komatsu has, certified the fluid mesh solution on their remote drilling operations, and we're working with them on how do we get the next validated design around that with them. So it's
So more ADS, not AHS, right? Is that, if I understand that correctly?
At the current time, that's correct.
Komatsu. Yeah, okay.
Okay,
yeah, and I guess the other thing that's worth noting here that we haven't talked about at all is the LTE technology, right? And there's a lot of our mining customers that are starting to deploy private LTE in their mining environments. Talk to me about how this kind of works with that. We're going to talk a lot more about that tomorrow. But why did we not do a validated design around LTE, or is that coming?
That is coming. Yeah, so we're working with that also. It's a matter of timelines and where we're at in the product line. So we're working with customers to get partners to get hardened LTE solutions that can be used as endpoints. And then we have obviously the Cisco packet core that we can use for the routing off of it, and then we'll work around that. The cellular option is a great option for some customers. It's a great option if you're trying to get a good throw, a good coverage, a lower throughput off of it. But what we're finding is that a lot of customers are trying to stay with the either fluid mesh or 802.11. Because once they own the infrastructure, now they're on, a free-to-use spectrum that they can use. So they have the capability for that, and they have the capability for higher bandwidths off of it if they're doing a lot of video for tele-remote
Right.
operations off of.
Hey, quick question. This, and I knew this was going to come up. I forgot to ask you. It's in the Q&A. When does 2.0 come out? We haven't seen it out there yet.
Hopefully in the next couple of days.
Couple of days. Okay, so actually, just I'll put this out there. He says a couple of days right now. He said a couple of days to me a week ago. So I mean, it's coming. It's like we thought it was actually going to be on the site by today, but unfortunately, it's not. So keep looking for it in the next couple of days. And if you don't find it and you think it's been a couple of days, feel free to reach out to us and we'll let you know if it is out there and you're just not finding it. We can point you to it for sure. All right. Let's talk a little bit about the different mining industrial solutions that are required within mining. Right. We talk a lot about the extraction process and the crush convey pieces, but there's a lot more to mining than just those processes. Talk to me a little bit about this slide.
Yeah, so in mining, some of the major constraints for all mines is how do you get water so that you can do your processing, and then what do you do with your waste, and then power. So if you look at, for example, in the state of Arizona in the United States here, Freeport-McMoRan operates 3 mines here in the state of Arizona. And Freeport-McMoRan is the largest power consumer in the state of Arizona, and they consume more power than the next 4 below them combined. Wow. So power is a huge thing, and start to look at when you go to Indonesia or to the Congo or some of these outlying sites, and there's not the power infrastructure there to be able to get it. So you have to create your own power companies off of it, your own power generation, whether that's coal in Indonesia, whether that's water in the Congo, whatever way you're doing it. And so there has to be a way to be able to manage that. And what we're working with on that is our power substation group inside the Cisco Validated Design group to be able to take that validated design and see how we can then customize that for mining use. Next is the waste management, to be able to do waste management and water recovery in the tailings ponds. And so it's a huge environmental impact. There's been, these tailing ponds, there's been instances in South America, in Canada, in the United States, where some of the dams have failed and entire towns have been, completely wiped out in a tailings pond incident. There's been incidences where, it went into the river and killed a lot of the livestock that's in there too. So these things, to monitor them for stability, monitor them for however you're using them, it is a very important part in the mining process. And what has happened in the past is that you have slopes managers that would manage the slopes and the tailings and they would drive and go out and take readings off of some of the monitors and then write them down on a piece of paper. And then when they drive back to the office, they put them in a spreadsheet. And so was a very manual process. And what we've done by going to digitalization and getting stuff like the LoRaWAN for a long range, low bandwidth, high battery life that can be used off of it. What we've done is we've enabled them so they don't have to drive out there. Now, all of a sudden, they have that data at any time that they want it, and it's brought into a spreadsheet form to be able to manage the slopes off of it.
Right. So digital operations actually applies to all of these, right? I mean, I talked about digital operations just before you came on. Really, that goes across all of these industrial areas. Is that fair to say?
100%. What we find a lot by enabling this digitization, as some examples and use cases is we've had surveyors before. They have to, drive out, take their survey, drive back to the office, upload their information. Whereas if you provide some kind of Wi-Fi bubble around the survey vehicle, so the survey vehicle connects back to the infrastructure that you have, or it connects over, LTE or 5G or any of the cellular, and then from there you broadcast a Wi-Fi around the vehicle, allowing the surveyors to not only download their maps but upload their information that they have without having to return back to the office. Same thing applies for for digital forms. What used to happen is,
Right.
customers would have to fill out a form and then enter it in. Now, if you have a digital form, you can move forward so much quicker inside the, whether that's a vehicle inspection form or that's
Yeah.
a site form for, the builds that are going on there.
That's awesome. Yeah, we'll talk a bit more about that in the collaboration section here just after we finish talking to you. That's awesome. And in terms of actual connectivity everywhere, obviously, is there one wireless technology that can kind of get you everywhere? Like, should we be, doubling down on one of these technologies, or what do you think about that? We're going to talk about, a whole bunch of different wireless technologies tomorrow. Do we really need all of them?
It's in our opinion that most definitely they're complementary to each other. There are places where Wi-Fi is a great fit. There's places where LTE 5G cellular is a great fit. There's also places where LoRaWAN, where the Cisco Ultra Reliable Wireless Backhaul is a great fit off of it. So it really is, what application are you using? How do you want to manage that application? What type of bandwidth are you after? And what type of coverage area are you trying to get into all of that? So those are huge questions that fit into it. But we believe that they are definitely all complementary of each other and not exclusive of each other.
Right. And that complementary nature isn't necessarily more expensive because you're duplicating wireless. Sometimes it can be cheaper, right? I mean, you might be covering an area with Wi-Fi because it, provides a lot of bandwidth, but obviously it's to cover a whole mine site might be too expensive for Wi-Fi, so it might make sense to do that with other technologies, right? So it's not necessarily a cost thing that you need to overlook, right? It's all of the different all the different decision criteria all kind of together, right? We actually didn't really talk about the architecture. You had an architecture slide in here kind of as to what pieces you specifically have in 2.0. There was also a question about where do you find the CVD once it's released? And I think Don put a link in the Q&A panel that should get you there. If for some reason you didn't take a picture of that link or copy it down or copy it into your browser, just do a Google search for Cisco CVD, and it'll actually take you right to that site. Cisco CVD will take you right to the site, and then you can scroll down to the table where all of the CVDs are in, and you can actually filter on mining category, and all of the mining CVDs will come up. Sorry, you were going to say something, Bruce?
No, I'm sorry, I had a call coming in. I had to decline it.
Okay. Yeah, you want to take us through this design just at a high level, and before we kind of jump into the next session?
Yeah, so the idea around this is things that move and need, a high bandwidth and low latency off of it. So we, tested on the dozer, on the shovel. We tested applications to emulate the dozer shovel. We've certified this at Caterpillar with the fluid mesh prior to the acquisition. And then we went back to what their certification design was and used it as our reference off of it. So we have, the idea is that on the haul truck, we have 2 radios off of it. So we have a make before break. We have the capability of switching from one radio to the other radio, make the connection, and then break the RF connection on the other side. Same type of thing with the drills too, is the drills will have the capability of doing a make before break. So you have a high reliability. Obviously on dozers, the real estate on a dozer for multiple radios is very limited. So single radio design was done on dozers. So the make before break doesn't exist off of it, but we still keep a low latency and high throughput off of it. And then on the shovel, the same type of thing. And one of those things on the shovel is because it's so extremely tall inside the mining area, it has such a great field of view to be able to make connectivity. And then obviously we did the testing for the point to multi-point, point to point for the distribution layer of it. And so this is our reference off of it for the design of how we would see it connected into the mine.
Cool. Question, I guess, about bandwidth. You've mentioned bandwidth a couple of times. Is that primarily related to channel size? Like, how would the channel size of, say, or the throughput of this solution compare with, say, LTE?
You know, I would have to say that it is definitely, you know, your channel size inside the wireless world. You know, we can do 20, 40, 80, 160 megahertz channel. We tested with the 40 megahertz channels on these. So we tested both 20 and 40 megahertz. And one of the reasons that we do that is because it's very difficult to find a mine that has the capability of using, you know, 80 and 100 megahertz channels off of it.
That's fair. Yeah.
So,
okay. There was one really intriguing question on the Q&A that I think I'd like you to talk to is around DNAC support, right? More and more now, I'm talking to mining companies that are saying we have DNA Center in our enterprise to do a lot of templating, automation, gold images, managing all of that stuff, right, on the enterprise side. Why can't we use that in the mine as well, right? And clearly you can with a lot of iOS XE boxes already, like the IR routers and the IE switches that are iOS XE. Does that also include the new boxes that are coming, like the Fluid Mesh, these that were built by Fluid Mesh before we acquired them? Those aren't obviously in that DNAC portfolio, but you talked about that new one that's coming out at the end of the year. Would that be iOS XE based as well, and would it be managed by DNAC, you think?
it will not in its initial release be managed by DNAC. Okay. You know, the Cisco Ultra Reliable Wireless Backhaul is currently not into the DNA Center. You know, it is obviously a need to roadmap to get there, but at the current time, it's not there.
Okay, so that makes sense on the Fluid Mesh image. If they were to boot that with a Wi-Fi image, would that then be manageable by DNAC?
It will at a limited base out of its.
Depends which image you've got on there.
That's correct. That's correct.
Okay, cool. Yeah, and we've seen that with other products too, right? I mean, you talked on the LTE front that we're working with partners to get the really hardened boxes, and they're actually embedding iOS XE into their partner boxes as well. So those will be managed by DNAC as well. So we'll have the full range right across the whole mine, and in Wi-Fi, and maybe eventually on the Fluid Mesh technology, but definitely in the Wi-Fi and the LTE, both of those we've got DNAC managed endpoints. So we'll talk a bit more about that tomorrow as well. Anything else you want to say, kind of as we wrap up here?
No, I think that you know, as we're moving through, we're always with our validated designs and our next generation validated designs. You know, one of the things that really helps us work through this, as an example, when we did the mining 1.5, I said that we worked with Sandvik and we went to their test mine. And then after that, we went out to their customers and worked with a couple of their customers. There's some videos out there off of it. You'll find the links inside the same place the CVDs are at. But we worked with their customers. So we're always looking for lighthouse customers so that, you know, not only can we ensure that it works with our product, with our software, with our partners' software also, but also in the customer environment, in the full environment, so that we get there. So, you know, I would put out there that as a customer, as we're moving forward, we're going to be looking for, you know, lighthouse customers that awesome. Would like to deploy the new access point into their deployment, whether that's with the Wi-Fi side, to migrate over to the Cisco Ultra Reliable Wireless, or Greenfield that wants to start with Cisco Ultra Reliable Wireless Backhaul.
Yeah. I'll just add to that. I think that's a great call out, right? And this is true for any kind of new technology we have coming down the pike. Is we do have lighthouse funding, right, and country digitization funding that we often try to bring into the first few opportunities where we're really kind of breaking new ground, so that we can bring in professional services to help walk you through some of this stuff, even in a POC environment, so that you're not learning everything from scratch with the Cisco engineers. We've actually got professional services that come alongside and help walk through some of those initial deployments, so that that the customer isn't carrying that load. So there's there's ways to make this less intrusive for customers to even, to be at the cutting edge of the new stuff coming out too, right?
Yeah, and then I saw in the Q&A they were asking about the underground. The link that Don posted has the underground CVD 1.5 in that link there.
Awesome. Thanks, Bruce, and thank you for joining us for the first session. Join us also for the second session by clicking the next video about industrial collaboration.